Hello everyone. This is a collaborative project between IBM Canada's OpenJ9 team, IIT Madras, and IIT Mandi. The title of the project is SPARE, that stands for Safe Portable Partial Analysis Results for Java Programs. Let us learn more about the same. We have with us Vijay Sundaresan and Daryl Meyer from IBM, Krishna Nandivada from IIT Madras, and my name is Manas Thakur. I am from IIT Mandi. We will start with a question to Vijay. Hello, Vijay. Can you please elaborate on the technical motivation of doing this project?
Sure. Thanks, Manas. So the IBMers involved in this project, Daryl Meyer, Andrew, and myself, work on the JIT compiler in the OpenJ9 JVM project. The JIT compiler, as you may know, is fundamentally limited in terms of the time that it can spend doing complex analyses because it is compiling your program at the same time as running it. On the other hand, static analyses work by doing their analysis in an offline manner. When the analysis is running, the program is not running. And the idea of this project was to see how far we could take a mixed approach, as in use static analysis in an offline manner, and then do sophisticated analyses that may be too expensive to do in a JIT compiler, and then consume that in the JIT compiler to improve the performance of Java applications. And the particularly challenging aspect of this is to do this in a secure way without causing any functional problems in the process. And the IIT team are really the experts in this area, so we're really honored to be working with them on this project.
Well, that sounds quite exciting. Krishna, can you please talk about the goals of the academic team in this project?
Thanks, Manas. Yes, sure. If you look at it, we recently had a paper in TOPLAS 2019, which is called as the PI framework. What does this PI framework do? It addresses this particular challenge that Vijay talked about. This is a challenge of realizing efficient whole program analysis. And what PI framework does, it takes a two-pronged approach, wherein in the static analysis time, which is compiling the source code offline at that to get the class files, it compiles the source code, gets the analysis, and this analysis is partial. In the sense, since we do not analyze the libraries, so this partial analysis results is sent to the target machine along with the bytecode. And at the target machine, this partial results is received and check that they are secure, they are safe, and then along with the library results, which are pre-computed. Again, remember these library results are partial results. These are merged. So the partial results of the application and the library are merged to obtain the complete analysis, right? Our goal in this project is to implement the PI framework, the Eclipse OpenJ9 framework, so that we can speed up Java applications. And one of the main optimizations target for us is reducing object allocation overheads. We also want to extend this idea to other analysis like data restoration.
Thanks for the comprehensive introduction, Krishna. As this is a joint project between academics and industry, can you also tell us about the expectation of the academic team from the IBM team?
We have great expectations from the IBM team. The IBM OpenJ9 team has lots of experience and understanding of the challenges in JIT compilation, and importantly, all the real-world issues which are otherwise not visible to an academic setting. We want to leverage the same, and thankfully we have a great team that we have here that is cooperating with us, and we are grateful to them.
Rightly said. Daryl, can you please also talk about the goals of the IBM team from this project?
Sure, Manas. Ultimately, we'd like to improve the performance of Java applications and advance the state-of-the-art of escape analysis optimizations. We would like to use the results of the Pi framework to improve stack allocation of objects and thereby improving performance of important performance metrics like garbage collection response times, application throughput, and memory footprint. Because we work in an open community, OpenG9, we'd like to see the results of this work contributed back to that community so that the broader Java community can benefit from our efforts.
Right, that sounds quite promising. Now, let us conclude with some status report about the project. Krishna, can you please tell us about where the project is heading and what are we doing currently?
Yeah, sure. We are currently understanding the internals of OpenGenAI. It's a complex piece of software. We are working on the design of two optimizations that we call as split escape analysis and optimistic stack allocation. We started the implementation of one of them soon. We are also making good progress on the data race detection tool that on which we have made a lot of progress. We hope something great comes out of this whole project. Thank you.
Thanks. That sounds quite great. Looking forward to see the developments as part of the project. We are also thankful to the IBM team for funding this project and to the Kessel organizing team for providing us the opportunity to present this work. In case of any questions, please feel free to reach out to any of us. Thank you. Have a good day.